Given question, 4-stroke single cylinder air cooled engine with fuel consumption time for 10 cc is 20.4 seconds and air consumption time for 0.1 meter cube is 16.3 seconds. Load is 7 Newton at the speed of 3000 rpm. The density of air is 1.175 kg per meter cube and specific gravity of the fuel is to be 0.7. Lower heating value of the fuel is 43 megajoule per kilogram and the dynamometer constant is 5000. Find air fuel ratio. Brake specific fuel consumption. Brake thermal efficiency.
Let us understand given data. This is the 4-stroke single cylinder engine. Volume of fuel consumption is given. It is 10 cc, that is 10 centimeter cube. But the standard unit is meter cube. So we have to convert this centimeter cube in the meter cube. Now volume of fuel consumption. So we will give the notation V to the base F. So Vf is equal to 10 cc. Now how to convert centimeter cube in meter cube? So 1 centimeter is equal to 10 raised to minus 2 meter. So here is cube. So 10 raised to minus 2 bracket cube and that is equal to 10 raised to minus 6 meter cube. So this is the standard unit we have to use in the calculation. Now time of fuel consumption. So it is 20.4 seconds. So this is the time. So we will give the notation TF. Then volume of air consumption. So it is VA 0.1 meter cube. Then time of air consumption. So it is TA 16.3 second. Then load is given 7 Newton. So load we will give the notation W. Then speed is given 3000 rpm, that is revolution per minute. So speed we will give the notation capital N. Then the density of air. So density of air notation is rho A. So it is equal to 1.175 kg per meter cube. Specific gravity of fuel is given 0.7. So from this specific gravity we can calculate the density of fuel. So density of fuel rho F, and how to calculate it? We have to multiply 10 raised to 3 to the specific gravity, that is 0.7 into 10 raised to 3 and which is equal to 700. So this is the density of the fuel rho F. Heating value. So this heating value is known as calorific value. So its notation is CV. So CV is equal to 43 megajoule per kilogram. Then dynamometer constant. So dynamometer constant we will give the notation C. It is 5000. Now we have to find out air fuel ratio, brake specific fuel consumption and brake thermal efficiency. Now we will first find out air fuel ratio. So for that we will first find out the mass flow rate of air and mass flow rate of fuel. So mass flow rate of fuel, that is the mass of air consumed. So mass of air consumed m dot A. So why dot? Because it is the flow rate. So whenever there is flow rate, then we have to define this in terms of kilogram per second, that is we should mention the time. So m dot A is equal to, formula is volume of air multiplied by density of air divided by time of air, that is VA rho A by TA. So volume of air VA 0.1, density of air rho A 1.175, time of the air consumption 16.3. Now if we observe, we will also verify these units. So this volume is given in meter cube. So I will write here the unit. It is in meter cube. Then density is given kilogram per meter cube. So I will write kilogram per meter cube. and divided by TA. So time is given in second. So divided by second. Now this meter cube is getting cancelled and the remaining unit kilogram per second. This is the unit of mass of air consumed. Now in the same way we will find out mass of fuel consumption. So same formula, Vf rho F by Tf. So volume of fuel consumption. So this volume of fuel consumption we have to refer in terms of meter cube. So how to convert this cc in meter cube? So we have to multiply with 10 raised to minus 6. So we will take 10 multiplied by 10 raised to minus 6. So I will take here multiplied by rho f. So density of fuel is 700 divided by time 20.4. So same unit, because if we go through this unit then we will get kilogram per second. So 343.13 into 10 raised to minus 6 kilogram per second. Now we will find out air fuel ratio. So this is the ratio of mass flow rate of air to the mass flow rate of fuel, that is m dot A by m dot F. So when we calculate we will get 21. So this is the answer of the first question. Now we will move to the next. So we will find out the power output, which is also known as brake power. So brake power notation is BP. So BP is equal to Wn by C, where W is load in Newton, N is speed in RPM and C is dynamometer constant. So when we put these values then we will get the answer in kilowatt. So it is 4.2 kilowatt. So this is the power output or brake power. Now we have to find out brake specific fuel consumption. So what is its a formula? So BSFC, brake specific fuel consumption, we have to take mass flow rate of the fuel multiplied by 3600 divided by brake power. Now why to take here 3600? Because this mass flow rate of fuel is given in kilogram per second and we have to convert this time second into hour. So it is in denominator. So how to convert this? So when we have to convert this second into hour, then we have to divide by 3600, because in 1 hour there are 3600 seconds. So it is in the denominator. So this term second, that is kilogram per second, is equal to this kilogram divided by 1 by 3600. Here is hour. Now this 3600 we have to take in the numerator. So same term we have to take here in the numerator. So m dot f is 343.13 into 10 raised to minus 6 into 10 raised into 3600 divided by this BP. So what is this BP? That is brake power, 4.2 kilowatt. Now we will also verify the units. Now for this m dot f, it is kilogram per hour. So it is kilogram per hour and this BP is in kilowatt. So it is in the denominator. So it is in the denominator. So if we observe, what is the unit? Kilogram multiplied by kilowatt hour. So we will write the same unit, kilogram per kilowatt hour, and answer is 0.29. Now we will calculate brake thermal efficiency, that is neta BTH. So its a formula is brake power divided by mass flow rate of fuel multiplied by calorific value of the fuel. Now we will consider its a standard units. So brake power we have to consider in kilowatt. So I will write here its a unit kilowatt divided by mass flow rate of fuel. It is in kilogram per second. Kilogram per second, and calorific value it is kilojoule per kilogram. So it is kilojoule per kilogram. So these are the standard units. Now brake power we will take 4.2 kilowatt, mass flow rate of fuel 343 into 10 raised to minus 6 kilogram per second, calorific value 43 into 10 raised to 3 kilojoule per kilogram, because it is given in megajoule. So for to convert this megajoule in kilojoule, we have to multiply with 10 raised to 3. So its answer is 0.2848. Now we will simplify the units. So this kilowatt is known as kilojoule per second. So I will write here which is equal to kilojoule per second. So this kilogram per second, it is in denominator. So I will transfer this second per kilogram. And this kilojoule per kilogram, I will write here as a kilogram per kilojoule. Now if we observe this kilojoule getting cancelled, second, and this kilogram is getting cancelled. So it's a unit, there is no any unit. So answer is 0.2848. But this is the efficiency, so we have to multiply with 100 and we will convert it into percentage. So it is 28.48% and this is the answer.